fractions. It's going to be partial fractions and decomposition, in fact. No, what is partial fractions? You see, what we are going to do is we are going to be given a so-called rational expressions or a rational function. A rational function, sometimes this rational function is complicated for application with various formulas. So what we're going to do, we are going to break it. We break it into the easier one. Okay, so there are going to be some formulas that can be applied only to special fractions. So if your fraction is not going to be a special, we are going to change it into the expression, into the special one. So this is the idea of the partial fractions. So suppose you be given a function, you see f of x equal to, as usual, numerators, and this is going to be denominator, okay, is a given rational, okay, rational function, okay. This is going to be rational function that the degree of the top, we assume that, remember I talked about this one about the proper and improper one. So like in fraction, if the top is going to be greater than the bottom, we say that this is improper. And sometimes we change it to the mixed number. It's going to be the same thing as here. So we suppose that f of x is nx over dx is a given rational function such that, okay, such that the degree of the top is going to be less than the degree of the bottom one. Otherwise, we can use long division, to divide it. So if not, okay, if not, or if it's needed, okay, use long division, okay, to change or to convert. Okay, you need it for a couple of cases to convert f of x into, okay, you know that you can convert it to the f of x equal to the, we divided, you make it a quotient, okay, call it g of x, and then we get r of x, the remainder, over d of x, where the degree, you know that when it's going to be remainder, where the degree of the top is less than the degree of the bottom. So on all the problems that I'm going to give you, you don't need to divide. But there are a couple of them in your book that you have to divide it. Okay, so we assume that we have a proper fractions. Okay, any question? The degree of the bottom is going to be, the degree of the top is going to be the smaller. Now what we are going to do is, we would like to write this fraction, this rational expression, as a sum, okay, as a sum of some other fractions that we call them partial fractions, okay? So this is the main fraction, but you would like to change it to the sum of some partial fractions. So we can do it if this d of x, the bottom one, can be factorable. Okay, so so what we would like to do is, we would like to, one can write f of x as a combination, as a sum, if you like, sum of, okay, partial fractions. So the partial fraction is going to be easier one, if you like. So what we are going to do is, there are going to be, there are something like four different cases that we'll be able to do it. So there are four cases. So we're considering the case 1. The case 1 is dx over here, you see. You can factor this one into the linear polynomials. What is linear polynomial? Linear polynomial is something like x minus 1, x plus 2, x minus 3, etc. It's just ax plus b. So the case 1 is dx is a product, is going to be a product of linear polynomials. Linear polynomials means this is d of x. It's going to be something like, x minus, let's say, a1 times x minus a2. It's going to be just a couple of them. Suppose it's going up to the x minus an. You say it's something like x minus 2 times x plus 2. Okay, x minus 2 times x plus 3. So suppose the x is a combination, it's a product of linear polynomials. If this is going to be the case, so what you're going to do is, okay, so if this is going to be the case, we are going to write f of x as, you see this is going to be the one, f of x as. So what we're going to do is, we are going to get some fractions. For each factor, we are going to introduce a fraction. So this is going to be x minus a1, okay, x minus a2. It depends how many do you have, up to the x minus an. So on the top is going to be the numbers that you have to find there. So these numbers on the top, we call it a1, a2, up to the an. In your book, they call it a, b, c, d. But I'm going to call it a1, a2, a3. It's going to be, it doesn't matter how many it's going to be. Okay, so for each factor, you're going to create one fraction. You see, these are partial fractions, because when you put them together, you get your f of x is the main fraction. So write f of x where these a1, a2, up to the an are going to be our constant numbers, are numbers to be defined or to be determined. Okay, you have to find it. You have to find these numbers. So it's going to be case 1. Okay, case 1 is dx is the product of linear polynomials. Let's try this one first, and then we go to the case 2. Okay, are you ready? This is the most popular case in application. Example, we wanted to write a partial fractions, say decomposition of this function f of x equal to 3x over x squared minus 4. You see, that's one. You see, the denominator is factorable. Is x squared minus 4. You can factor it into the x minus 2 times x plus 2. So the denominator is the product of two linear factors. Okay, so the solution is going to be, you are going to write f of x is equal to, okay, this is going to be 3x, and the top is x minus 2 times x plus 2. Okay, now we break it into one factor for x minus 2, okay, plus one factor for x plus 2. On the top, we put the a1 and the a2. You see? So you compose it into the sum of two partial fractions, a1 and a2. Now we have to find the a1 and a2. Now how are you going to do it? You just continue over here. You see, find the common denominator. So this is going to be equal to the common denominator would be x minus 2 times x plus 2. The top is kind of cross multiplication. It's going to be a1. The missing factor is x plus 2. Okay, plus a2. The missing factor is x minus 2. Now we have the equality of two fractions. You see the given one and the one that you provided. So this is going to be two fractions. The numbers are the same. Since they are equal, so the top must be also the same. So you let the top terms to be equal to each other, okay? The numbers would be the same. So the top term must be equal to each other. Are you done? So write the top term and let them to be equal to each other. So what you have on the top, we have a1, okay? So we have a1 times x plus 2, and we have a2 times x minus 2, and on the other side you have, okay, on the other side you have a 3x. You see that's going to be 3x. Now you see, this is going to be a kind of an identity. So this means this is true for all, okay, for all x, for all value of x, because it must be true all the time. So what you would like to do is you would like to find the a1 and a2. In order to find the a1 and a2, you need two equations. You see two equations. So in order to create two equations, since this is true for all value of x, pick two numbers for x. Okay? You pick, since this is true for all the numbers, so it's going to be for two numbers that you're going to pick. You pick two numbers, you substitute, so that give you two equations. The two equations, two variables, then you can solve for the a1 and a2. But if you pick a nice numbers, you'll be able to find them quickly. So the best numbers are going to be, you see, all the numbers. So pick a numbers that get rid of this one right away. If you put x equal to 2, this would be 0. So quickly we can find the other one. If you want to get rid of this one, you pick negative 2. So negative 2 and positive 2 are going to be best numbers, okay? And these are coming from the denominator, you see. This denominator, x minus 2 would be 0 at 2, and x plus 2 would be 0 at negative 2. Of course, you can use any number you like, but the other numbers, you have to solve a system of two equations, two variables, okay? So pick the zeros of the denominator. So I pick x equal to 2. You substitute on the both sides, so it's going to be a1 times 2 plus 2. And this is going to be a2, 2 minus 2. Okay, we don't write it down in back. That's going to be 3 times 2. So as you can see, this would be 0. This would be 0, 2 and 2 would be 4, so that gives 4a1 equal to, okay, equal to the 6. Then you can find the a1. a1 is equal to the 6 quarter, and when you simplify it, a1 would be 3 half, and you find it a1. Any question? So these numbers are optional. Why not best, pick the best one? The best one is going to be zeros of the denominator. So that's x equal to 2. So now we pick x equal to negative 2. If you pick x equal to the negative 2, this would be out. So that gives a1, okay, a1. Now that's going to be negative 2 plus 2. And this is going to be a2, negative 2 minus 2. Okay, it's equal to the 3 times negative 2. Remember, both sides of the equation, same number. Now this time, this would be 0. So we are going to have negative 2 minus 2, negative 4. So the negative 4a2. Negative 4a2 would be what? Would be negative 6. Would be negative 6, and what is going to be a2 equal to negative 6 over 4. Okay, and you simplify it, that give a negative 3/2. So your A2 is negative 3/2. You go back, you have to give us the decomposition. So you start with the 3x over x squared minus 4. Now we can break it into, you see, that was x minus 2a1. This is a1. A1 is 3/2 plus, and the other one was, okay, a2 negative 3/2 over x plus 2. And you are done. You see, when you are in calculus, that integration that I talk about it, it can be done only when the factor is just a linear. So this is not a linear factor, x squared minus 4. That's why we break it into two parts to be able, okay, to be able to take care of it. Because these functions are easier to handle, to take these type of ideas. Many applications. And there are some shortcut, to do it. I'll talk about it later, because I wanted to do the algebra. Otherwise, you can do it, in a second, really, to get these numbers right away. But this is the way we are going to do it. Any question? So that's the most general case, or the best one. So we did, okay, d of x was, we can break it, or it was a product of the linear factors. It depends, usually have 2, 3 linear factor, just put them together and nicely find out. So you let the top two equal to each other, and since it's true for all values of x, so pick a couple of nice numbers, zeros of the denominator. When they are available, that's going to be the best case. Okay, that is case 1. Any question? Now, what's going to be case 2? You see, the case 2 is very similar to the case 1. The case 1, look at the case 1. You see, the case 1 is, they are the product of a linear factor. So the case 2 is, maybe one of these are going to be repeated. So it's going to be a repeated factor. This means there's going to be a power here. Okay, maybe x minus 2 is squared. In this case, there is no repetition. There is no repetition. But suppose one of these are going to be repeated, okay? So what are we going to do for the repetition? You see, when we break it into the partial fractions, the number of the fraction that we use depends on these numbers that we have. So if there is going to be a repetition over here, this is going to be x minus a1 squared. So you have to write one for x minus a1, and the other one for x minus a1 squared. So it depends, the repetition, the power that we have, you provide the complex fraction. Because always the complex fractions, the numbers must be the number of these factors that we're going to have. So we call it a repeated factor. So the case 2 is going to be, case 2, that is a case 2. So what is going to be and that's a case 1. Write it down so that you know it. It's a case 1. Okay, case 1.
In case 1, sorry.
Yes.
In case 1, when you got A2, was it negative 6 divided by negative 4? Because wouldn't that be a positive?
Negative 6 divided by, you mean A2?
Yes.
So I have a negative A2 over here, and yes, you are right. Yes, you are right. Okay, that's fine.
So would you just write it with a positive?
Yeah, yes.
Okay. I was just checking if it was written.
Yeah, very good. Yeah. Let me double check it. Yes, when you cross multiply, so that give you 3x and the 3x, 6x. Yes, you are right. Thank you. Okay, So let's see what's going to be case 2. So the case 2 is dx. Okay, so this is going to be the case 2 is the case that the dx, okay, dx, if you like, contains a repeated factor, a repeated linear factors. Let's say that repeated factor, we give it a name. Okay, so that name I'm going to call it, x minus a. Suppose to the power k, it's going to be just a square root there. So dx contains a repeated factor. Okay, repeated factor or factors. Repeated factor, let's say x minus a to the k. If this is going to be the case, okay, so what we're going to do is we are going to for this special one. So in this case, we are going to add, okay, add the following. Is going to be, x minus a, let's say a1, then it's going to be x minus a squared, okay, a2, it depends on the power, just keep going, a k, x minus a to the k. You see, you are going to add this one to the partial fractions decomposition of f of x. So this means for the other factors you already got some. Okay, for the x1, a1, a2, a3, you already got the common, partial fraction decomposition. But when we get to this repeated one, you have to repeat this. So for example, if it's going to be x minus a to the fifth, you write x minus a squared to the third, to the fourth, to the fifth. So you are going to add 5 more fractions to the original one. Okay, so it's going to be repeated one, and this is going to be your extra job that we're going to have. Okay, so let's try this one. Any question? Let's write it down so you know the difference. So this is going to be the case. We wanted to, okay, again write a partial fraction, a partial decomposition, partial fraction decomposition, partial fractions, partial fraction decomposition, okay, decomposition of this function. You see we got the f of x is equal to, okay, f of x equal to the, suppose on the top we have 2x minus 1, okay, 2x minus 1, and on the bottom we have something like x times x plus 1 all square. You see, that's the case. So we have one factor x, you see, the other factor is x plus 1 square. So the second one is kind of a repeated factor, okay? So this is going to be a repeated factor that we have to take care of it. Okay, are you ready? Solution. So what you are going to do is, this is your f of x is equal to, so you have two factors. The first factor is x, so put the a1 on the top, plus the second factor is x plus 1, put a2, but it's repeated. So repeated, you repeat it, it's going to be x plus 1 all squared, a3, it's done. You see, you have to go up to the repetition, if we call it multiplicity. If it was 3, so you have to do it 3 times. Okay, it takes time, so we usually give you 2. Okay, so just make sure don't miss it. So the usual one is x. For x plus 1, you are going to write 1. But since it's squared, you have to go on to get to the up to the squared. Okay. Now to the right, you continue. You find the common denominator. Okay, put them together nicely to get your common denominator. Okay, so I'm going to go to the next page to explain it. Any question over here? So what I have is I start with the fraction, the function. So the function was 2x minus 1 over x times x plus 1 squared. So what I did is I just repeated so I can have all of them, so I can find the common denominator. So this is what I have. Okay, x plus 1 all squared. So I'm going to find the common denominator. The common denominator would be x times x plus 1 all squared. Now the top, you see, is going to be a1. So x done, you see, this is x times x plus 1. So x done, and the leftover is going to be x plus 1 all squared. Okay, plus a2. a2, one of these x plus 1 would be done from the common denominator. So that gives you x times x plus 1. Okay, plus a3. In the case of a3, x plus 1 squared done. So that give you x. Any question? So the common denominator is going to be the product of the factor, and you know that just consider the missing factor. So this is x and x out, so that gives you x plus 1 squared. Over here, one of the x squared would be out, so that gives you x times x plus 1, and the last part, x plus 1 square out. Okay, now you get the top to be equal to each other. Okay, the top to be equal to each other, because this is the condition for two fractions to be equal to each other. So I start with the other side, so it's going to be a1 x1 plus 1 squared, okay, and plus a2 is a2x times x plus 1, and we have the a3x. Now this must be equal to 2x minus 1 as usual for all x. Now you have three unknown, a1, a2, a3. So you need three numbers. Okay, three numbers again. Get the nice one. The nice one are going to be the zero of the denominator. This denominator would be 0 at x equal to 0. So we get x equal to 0 is one of them. X equal to -1 is the other one. But since this factor is repeated, you don't have the third number. You see, you don't have the third number. You have to pick a number yourself. Okay, so the nice numbers, you are going to have only two nice numbers. The third one, just pick something nice. Okay, so that's the condition for this one. So what I'm going to do is just check the number that we have. Okay, so I check x equal to the 0 first. X equal to the 0, put it over here, so I'll give you a1 0 plus 1 all squared. You see this would be 0 because of the x. Okay, that would be 0. You don't have to write it down, and that would be 0 too. So that would be 0. Okay, because of the x equal to the 0, you have to put it over here, so it's going to be 0 minus 1. So what we have, 0 plus 1 would be 1, 1 squared, so that gives a1. a1 equal to what? Equal to the -1. That would be your a1. Any question? So I pick x equal to the 0 because this is it. This denominator would be 0 at 0. And when you substitute, everywhere you see the x, that would be disappear because of the 0. Okay, now we get the other number. Other number is x equal to -1. So if you put a -1, this would be 0. Because -1 plus 1 would be 0. Okay, this would be 0. because of the negative 1. Okay, and here you will get it. It's going to be plus a3 times negative 1. The same on the other side, 2 times negative 1 minus 1. Okay, so these are out, so that give a negative a3. Negative a3 equal to the negative 2 minus 1, which is a negative 3. So a3 would be 3. So it's going to be a3. Any question? Now you are done with the nice number, but you have one more to find. You have to find a2. Okay, now you have to pick your number yourself. Okay, pick something nice. You have this 0 and negative 1. You can pick x equal to 1 if you like. You can pick x equal to 2, 10,000, 1 half. But pick, a number that's going to be easier to handle. Okay, so since we don't have any roots, any factors on the denominator, we have to pick something ourselves. So we pick 1. Okay, substitute. So that gives a1 times 1 plus 1 all squared plus a2 times, x is equal to 1. So that gives 1 plus 1 plus a3, x is equal to 1. And on the other side, so that gives 2 minus 1. Nothing would be 0 this time. 1 and 1 would be 2. 2 squared would be 4. So that gives 4a1. 1 and 1 would be 2. So that gives 2a2. And the a3 equal to 1. You see, you are going to have a relationship between the a1, a2, and a3, but you already got the a1 and a3. Substitute to get your a2. Okay, so a1 is equal to the negative 1, and a3 is equal to 3. We substitute. And so we substitute over here, so that gives us a negative 4. Okay, and 2a2 is the missing one. a3 is 3, equal to 1. Simplify that, giving negative 1. So it's a negative 1 plus 2a2 equal to okay, equal to 1. Okay, so that gives it 2a2 equal to 2. So a2 would be 1. a2 would be 1. Now we go back and give us a partial fractions decomposition of the function. Okay, any question? So that would be the final answer. F of x is equal to a1 over x. a1 is a negative 1. Negative 1 over x plus a2. a2 is 1. a2 over x plus 1. Plus a3. a3 is 3. 3 over x plus 1 all squared. That's it. You see, it's a very nice version when we decompose it. The result can be easily handled, and you'll be able to do the job, to get the numbers. So this would be case 2. The case 2, we have a repeated factor. We have a repeated factor, so you have to repeat it. You have to repeat it because you have to have as many partial fractions as the factors that you're going to have. So it doesn't matter, it's repeated. So you repeated your partial fraction so that you have you get up to the power is the squared. Okay, that is case 2. Any question? So ready for case 3. Now, what is going to be case 3? Now the case 3 is going to be, you see, when we factor the denominator, there is going to be a quadratic polynomial. You see, they are linear. One of them is going to be the power of the x would be 2, and we cannot factor it. like x squared plus 4, x squared plus 1. You know that x squared minus 4 can be factored, not x squared plus 4. So what are we going to do if one of these factors is going to be, you may have some of these linear one. We already talked about the linear. So you may get a quadratic one. If you get a quadratic, remember these partial fractions are, all of them are proper because we emphasize that the degree of the top always must be less than the degree of the bottom. As you can see, this is the degree is 1. You put a constant on the top because the degree of the top is 0. So 0 is less than 1. It's the same thing for this one. So in this case, since you are going to have x squared, so you have to put something on the top with a smaller degree. So when the degree of x is 2, so on the top it's possible to have a 0 or to have the 1. So that's why we have to change the top. We have to change the top into the something like ax plus b to get those numbers. Okay, so it's going to be, the algebra involved is going to be a little bit more, but it's not difficult. Okay, so that's the one, we call it case 3. Okay, case 3. Case 3, that d of x contains a, we say, non-factorable quadratic, quadratic expressions. So dx contains a non-factorable, they call it irreducible, non-factorable, contains a non-factorable quadratic, okay, non-factorable quadratic expression. Expression like, like ax squared plus bx plus c, for example. So one of the denominator would have, okay, would have this one over here. So what we are going to do is, you just take care of this. We already talked about the other. So we take care of this one. So what we are going to do is, in this case, okay, in this case, you are going to add, you add this one. So for this that you got over here, it's going to be, denominator is going to be as is, ax squared plus bx plus c. On the top, you're going to have something like a1x plus, I'm going to call it a2, some people they call it b1. So a1x plus a2. Okay, since the degree is 2, so the degree of the top must be 1 less. So the 1 less, the degree of x must be 1. So you may get a constant here. So in this case, we are going to add this one to the already partial fractions, decomposition. Okay, decomposition of your function of f of x. Okay, so you do whatever, for the other factors, we do what we talk about it. Okay, so you get to this one, so, oh, it's quadratic. Okay, it's quadratic, so I have to put something, the power is 2, so I have to put the x on the top, a1x plus a2. So it takes algebraically a little bit more involved in order to be able to find it, but it's not bad. Okay, so let's check to see how we're going to handle these type of problems. Any question? So let's see what we are going to have for this one. This is going to be example. So the example is, again, we want to write or write the partial or a partial fractions, decomposition decomposition of this function. You see, f of x is equal to, okay, f of x equal to, let's say, on the top, you may have x squared minus 3x minus 3x plus 1, and down the bottom we may have okay, this is it, we may have x minus 1 times x squared plus 1. Okay, that's going to be 1, or x squared plus 4. Why not? You see, it's going to be non-factorable. So we have one linear factor, which is x minus 1, and one quadratic factor, which is not factorable, x squared plus 4. If it was x squared minus 4, we should, we would be able to factor it, but not this one. Okay, are you ready? Solution. There is going to be just a technical point regarding how we're going to find those coefficients, which is a little bit different. Okay, solution. So a bracket, and this is it. You're going to start with the given one. It's going to be x squared minus 3x plus 1. And over here we have x minus 1 times x squared plus 4. So I have one linear factor, x minus 1. It's not repeated, so I have the a1 on the top. It's done with the first one, but the second one, we have x squared plus 4, which is quadratic. So I have to put a linear on the top. I've already got the a1, so I'm going to call this one a2, a2x plus a3. Again, some people, they call a, b, c, d. They don't like this a1, a2. It's just up to you. That would be fine. Any question? So make sure don't miss it. This is a linear, x minus 1. So on the top is going to be a constant, a1. But this is not. The power is 2. Since the power is 2, something with the power 1. You have to put on the top. Okay? So find the common denominator. So what's going to be the common denominator? The common denominator would be just x minus 1 times x squared plus 4. So what's going to be on the top? On the top, a1, the missing factor is x squared plus 4. Okay, and this one over here is a2x plus a3, okay, times x minus 1. Okay, now let the top to be equal to each other. Okay, the top, I start with this one. It's going to be a1, okay, a1 times x squared plus 4, okay, plus a2x, okay, a2x plus a3, and times x minus 1, and this is going to be equal to what? It's equal to the x squared minus 3x plus 1. So this is going to be the situation that you are going to have. Now let's see how we're going to handle this one. Okay. You see, we usually check some numbers. This is again true. This is true for all x. You have a2, a3, okay? So you need 3 numbers. But we have only one number, you see? You have only one number, x minus 1. So you have this option that you can use this one number, okay? One number, and then the leftover is going to be 2 more numbers, okay? So what you are going to do is you are going to pick 2 other numbers to be able to do it. This is one way to do it, and there is a second solution. So I'm going to use this one first, and if you like, I can explain the other one too. So this is going to be the case. So substitute the next number that we have. The next number is the x equal to 1. So we go with the x equal to 1. That gives one of these factors quickly. So this would be a1. If you put x equal to 1, that gives 1 plus 4. You see the second one would be 0 because of this factor. You got the x minus 1 over here. But you have to do it on both sides. Okay, both sides, so that gives us 1. Sorry, it's going to be 1 minus 3 plus 1. Okay, x equal to 1 on both sides of the equation. So that gives us a 5a1. Okay, that gives 5a1, and this is going to be a negative 1. Okay, this would be a negative 1, so a1 is equal to the negative fifth or 1/5. That's going to be our a1. Any question? You see, you are done with the nice numbers, and you have 2 more to go. Okay, so you have to pick 2 numbers yourself. Okay, something nice. So, for example, we can pick 0 if you like. So I can pick 0 and negative 1 if you like. Okay, as the other 2 numbers. So it takes a little bit more time than the other one. So we put the 0 here. So we have the a1. You have to operate it. 0 plus 4. So it's going to be plus. You put a 0 here. So that gives 0 plus a3. And this is going to be 0 minus 1. Okay, 0 minus 1. And you put the 0 here, that gives 0, 0 plus 1. Okay, so I put x equal to the 0 and substitute. So what you have? You have 4a1. And over here, we get the minus a3. Okay, that's it, minus a3 equal to 1. No a2. But you already got the a1. a1 is equal to the negative fifth. Now we can substitute. So that gives 4 times negative fifth minus a3 equal to 1. Easy. So that gives negative 4/5. Okay, minus a3 equal to 1. So you have to find it. What we're going to do is, this is a negative a3, and that would be 1 plus 4/5. So it's going to be a3, this is going to be, what's that, a 9/5. So a3 would be negative 9/5. This is going to be your second unknown. Any question? So this is always going to be the case. Okay. So we have to check one more number to find the a2. So we check the 0 and 1. So another number would be, we check the negative 1. Okay. So how about x equal to the negative 1? If we put the negative 1, this is the equation that you have. You have to put the negative 1 inside. So what's going to be it's going to be a1 times, in the first one is going to be 1 plus 4. Okay, plus, that gives a negative a2 plus a3, and the inside is going to be negative 1 minus 1. And on the other side, if you put the negative 1, that gives 1 plus 3 plus 1. Okay, so on both sides of the equation, we put the x equal to the negative 1. Now, put them together. 1 and 4 would be 5a1. And this is going to be a negative 2. Okay, it's going to be negative 2. It's going to be a positive 2a2 minus 2a3. And on the other side, we get the 5. Okay, so that would be the resulted equation this time. Okay, but what we have? You have the a1, which is a negative 1/5, and the A3, which is a negative 9/5. So you substitute here to get your result. So it's going to be 5 times a negative fifth, 1/5, plus 2A2 is missing, minus 2A3, negative 9/5 equal to the 5. So we have to simplify it. So that gives you a negative 1, because this would cancel out. And that gives you 18/5 plus 2A2 equal to the 5. So negative 5 and the 18, that gives you 13/5. 13/5 plus 2A2 equal to the 5. And we move the other one to the other side. So it's going to be 5 minus 13/5. Okay, 25 12/5. So 2A2 is going to be 12/5. And if you divide by 2, so A2 would be 6/5. So that give you A2. It takes a little bit more time to do it, but it's not bad. It can be done. Okay, there is another method. I'll show you that method too if you like it. You can use it, but this method is not bad. So we have the A1. We are not done. You have to give us the decomposition. A1 is a negative 1/5. A3 is a 9/5 and 6/5. So this is going to be the decomposition of the function. F of x equal to, okay, it was A1 over x minus 1. So it's going to be negative 1/5 over x minus 1. Okay, plus A2x. A2 is 6/5. Okay, 6/5 x. And the A3 minus 9/5 divided by x squared plus 4. So that gives you the final answer to get these numbers done. Okay, so this is going to be one method, which is not bad. It can be done, but there is another method. I show you that one too, so you can pick the one that you like. Okay, some people like the other one to get, but this is easy. Okay, any question? You just make sure the operation would be all right. So the other method is, you see this one? We can multiply it. We can multiply this one, make it as a, okay, make it exactly like a polynomial, the quadratic expressions. So you have the equality of two polynomials. So two polynomials of a second degree are the same if the coefficient of those monomials are the same. It means the coefficient of x squared is 1, so you just let it to be equal to the coefficient of whatever we got over here. And the coefficient of the x, the same thing. Then you have a system of three variables to solve. So some people find that method easier. And you are not going to have a very general one. If you are going to be taking calculus 1, 2, 3, then you get very much involved. But mostly really that case 1 and case 2 would be enough. This is the one that we are going to consider. Okay, the method of your book are going to be just they substitute the numbers for all of them to give you those okay, those numbers. I'm just checking to see if I need to explain. Yeah, I explained that method too. Maybe you like it. Okay, so what I'm going to do is the second method, multiply. Simplify this one. Okay, you may like it. So method 2, it's nice to know it, see. method 2, the one that we're going to talk about, is going to be very brief one. But it's nice to know the methods in case in future. So I'm going to take it from here. You see, I have a1 times x squared plus 4, and that was a2x plus a3 times x minus 1 equal to, okay, a2 plus a3 equal to the x squared. You see, x squared minus 3x plus 1. Let's see what's going to be the method 2. For the method 2, you have to multiply this one and simplify it. Write it down as a quadratic expression, okay? So multiply it. So what's that? It's going to be a1 x squared plus 4a1. Okay, then you have to fold this one, just multiply, go forward. a2 x squared, a2 x squared, and minus a2x. I'm just using the FOIL method, plus a3x minus a3. And on the other side, we get x squared minus 3x plus 1. Okay, I just multiply them together. Now put them nicely together, organize it as a quadratic. So what you have is, to look at these terms, you have the a1x squared and the a2x squared. So factor out the x squared to get the coefficient. So we get a1 plus a2x squared. Okay, that's your x squared. Then try the x's. So you have two x's. So this is going to be plus. The coefficients are going to be a3 minus a2 times x. And the constant are going to be 4a1, okay, minus a3. And on the other side, we get x squared minus 3x plus 1. Okay, so I just multiplied, I did the algebra, and I put them nicely. I have 2x squared, so I factor out the x squared. I have 2x, so I factor out the x, and I have two constant. You see now, there you are. You see you have two polynomials. Both of them are quadratic. They are equal to each other if they see if the coefficient of the monomials are going to be the same. Over here we have the x squared, you see. These two must be the same. So that gives you a1 plus a2 equal to what? Equal to 1. Then these two must be the same. So a3 minus a2 must be equal to negative 3. And finally, these two must be the same. So that's going to be 4a1 minus a3 to be equal to 1. You see? Now you have a system of three equations, three variables. You have to solve this system. Okay? To solve this system, you pick these two. You know that you have to eliminate one of these variables. Sometimes it takes more time to get these methods, but I just wanted to show you. You see these two would cancel out. So that gives a1 plus a3 equal to the negative 2. So consider these two together. Okay, so you have 4a1 minus a3 equal to 1, and a1 plus a3 equal to the negative 2. Now add them together, these two would cancel out. So that gives you 5a1 equal to the negative 1. So a1 would be negative 1/5. Okay, just put it somewhere here to get the a3. So that gives you negative 1/5. plus a3 equal to the negative 2. So a3 would be negative 2 plus a fifth. So that gives you negative, is a negative 10 plus 1. So that gives negative 9 fifth. So a3 would be negative 9 fifth. Then you need the a2, put it in the first one. So in the first one, you have a1, okay, is a negative 1 fifth, plus a2 equal to 1. So a1 is equal to the 1 plus 1 fifth, which is a 6 fifth. So a2 would be 6 fifth. Okay, it's the same answer. But the other method is simplifying, easier. So that give you the same number. You get the negative 1 fifth. This is 1 fifth and the 6 fifth. Okay, just pick the one that you like, because you may get one of them, then you'll be able to do it for us. Okay, so this is the partial fractions when you have one one quadratic expressions to get these numbers. There is a fourth case. I just explained it, but we're not going to give you that one. The fourth one is if this is repeated. You see, if there is a public here, that it's like the linear one. So you have to write it twice. You get one for x squared plus 4 and one for x squared plus 4 is squared. So the coefficients are going to be much bigger, and then you have to use the second method to do it, and it takes times to be able to do it. So I just explained it, but we are not going to consider that one because we do too much for the college algebra. Not bad, but just knowing it would be enough. We are not going to question you in this one, but we talk about it so that we finish it. Okay, case 4 is that the dx dx contains a repeated quadratic factor. Factor, let's say ix squared plus bx plus c, let's say to the k. It's going to be a square at most. Okay, if this is going to be the case, you are going to add, you see, quite a lot. Add, this is ax squared plus bx plus c. This is going to be a1x plus, let's say, b1. And then you have to repeat this one. It depends how many times you have it. Okay, it's going to be a square, so it's going to be a2x plus b2. You just keep going to get to the ax squared plus bx plus c to the k, and this is going to be akx plus bk. And imagine that, even if you have a square, it can be done, okay, but it takes quite a, because you don't have any numbers, so you have to use the second method to put them together. Algebra involves going to be quite a lot, but we are not going to give you this type, just for your information. But the other one, we give you one question, it's 2 parts. One question, 2 parts on the next test and on the final. So, usually give you one with the linear factors, and the other one would be one with the quadratic factors, and just put them together as one question, but not this one. Okay, so that is section 6.4. I give you a break, we come back. Section 6.5 is very easy section. We are going to talk about system of inequality in two variables. It's all geometry. You don't have much algebra, okay? But there is a very nice application of those type of idea that you may not think about it, but there are going to be the one. Okay, so give it 10 minutes, we come back and we finish that section too, okay? So see you in 10 minutes. Oh, I'm sorry. This is, what's the question? A2 to be, which A2 do you want? It's the last one that I did. A2 is a 6/5. Oh yeah, this is when you talk about it. Okay, yes. So the idea of the next section is a very easy idea. Just remind you, probably have seen this type of ideas before, but we have to check it. So what we're going to do is we are going to consider a system of, because we already talked about system of a linear equation, okay? So we're going to consider system of linear inequalities. Okay, how we're going to handle these type of problems, and then we talk about it first, and then there is application in the next section that we talk about it later. So this is 6.5. Okay, this is going to be 6.5, and we are going to consider the systems of inequality. Okay, systems of inequality. Okay, a system of inequalities. Okay, so you are familiar with the system of the equation. So how about system of inequality? You see, this is going to be, you are going to have two linear inequalities together, and then you want to find the solution. I just remind you what you do with the one equation. Just make sure you remember this type of ideas. Then we do it with the system. Okay. So we review first. Just make sure that you know what we are going to talk about it. You see, for the inequality in an inequality in two variables, of course, we cannot solve it. So what we do is we graph. So we graph as we do it with a linear line. Then let me just give you an example to remind you. You see this from the past, from algebra course. You want to graph each inequality. Okay, for example, if you want to graph this one, let's say 3x plus y less than equal to the 6. You want to know what's going to be the graph of this inequality. So what we do is we usually graph the equation first, or equality. Okay, equation. So what we do is we graph this one first, 3x plus y equal to the 6. Okay, it's easy to graph. You need 2 points. So we go with the intercepts, x and the y. If you replace the x by 0, y would be 6. And replace y by 0, 3x equal to the 6. So that gives you 2. So this is going to be the case. Okay. So we locate these points. We have 0, 6. X0, Y6 going to be 1, 2, 3, 4, 5, 6. This is 1 point, and we get a 2. 1, 2. Okay, we're going to connect these 2 points together to get the line. If there is equality sign, the line is covered. We use the solid line. If this equality is not given to you, we use the dot line. So in this case, it's going to be a solid line. You see, this is going to be a solid line. Okay. In the case of the equation, the graph of the graph of the line is going to be every point on the line. Okay, on the line. When it's less than or equal to, you see this line would divide the plane. This is going to be the plane into two parts, upper part and the lower part. Upper part greater than, lower part less than. Then you identify which part are going to be interested in. Okay, it's not the case that as soon as you get less than equal to, it's going to be always lower. It depends on the sign of the y. So what we did in algebra course, they ask you to test the origin to see where is going to be the origin. You see the origin is, if you test the origin, okay, test the 0, 0 in your equation, So in this equation, which is 3x plus y less than equal to the 6, if you test the origin, so that gives you 0 less than equal to the 6. 0 less than equal to the 6 is going to be true. So since it's true, you check to see where is the origin. Origin is below the line. So the solution to this line is going to be the lower part. Okay, you check the 0, 0. If 0, 0 satisfy, this means 0, 0 is in the region, in the solution region. So in this case, the 0 is below the line. So you are going to shade below the lines, and we say that this is going to be the solution of the inequality. Okay, so the line, if this is going to be strictly less than, you are going to write you draw a dot line, but otherwise it's going to be a solid one. Okay, any question? Remember these type of ideas. So the case 2 is going to be a special case, something like y y greater than 3, y greater than 3. So you graph the you graph y equal to 3 first, which is easy. It's going to be a horizontal line. Okay, you pick the 3, 1, 2, 3. It's going to be horizontal line. Since there is no equality sign, so this line must be a dot line. You see, we are going to get a dot line to just identify that this is not going to be part of your graph. And of course, greater than means you go up, less than you go down. So in this case, this is going to be the region, the solution region, if you like. Any point on the top in this area is going to be the solution of your inequality. You know that's going to be y equal to the 5, 6, 7, 8, 9 are going to be all in the region. Okay, so this is the next one. Any question? The other special case that we have to know is this one, x less than a negative 4. Okay, x is less than negative 4. So what we're going to do is we are going to graph x equal to the negative 4 first. Okay, this is going to be the graph of, and this is going to be a graph of a negative 4. And there you are. This is negative 4. 1, 2, 3, 4. So since there is no equality sign, you get the dot line. Okay, dot line. And x less than negative 4. You know that this is the number line. Number line less than negative 4 is here. So that gives you the graph of the graph of your inequality. Okay, so this is just one inequality. Any question? So this is going to be just one inequality. Okay, the way we're going to do it is going to be this form. Now, what we are going to be interested in is a system of inequalities. Okay, for the system one, so what we do the same thing. Okay, we may have a couple of inequalities. So we do the same thing. We shade the region, solution region. But for inequality, the region of the solution is the common region. Okay, so it's going to be a place, a region that they share the points. So that gives you the solution of the inequalities. Okay, and that's the idea of this section. Okay, any question? So now let's copy this one, but we do it twice for the system of inequalities. And then we get this, see the applications. Okay, so it's going to be the same thing. So we start working on some examples. Okay, so as we talk about, we graph each one of them to get these numbers. I can give you one example first. You have some sort of example of this format in your book. Okay, just ask you to check the solution. Okay, it's like the equation, really, you know it. They ask you to determine, okay, determine whether the given point, okay, the given point or points, okay, whether the given points are solutions, okay, are solutions of, okay, system, solution of the system of inequality. Okay, the system is this one. Okay, the system in question is negative 2x plus 5y. Okay, this is greater than or equal to 3. Then the second equation is y is less than 4. And the third one is negative 4x plus 2y less than 7. Okay, less than 7, and they give you 2 points to check. Okay, so the points that we want to check are going to be, okay, the first point is negative 6, negative 6 and 4. That's the first point. And the second point that we want to check is the negative 8 and the negative 2. Just get the idea that you can have, you know, more than one, two equations. Okay, it's like testing an equation. So what we're going to do is you're going to drop these numbers in to find out if they satisfy. The answer is yes. Otherwise, the answer would be no. Okay, so I'm going to label this as 1, 2, 3 because you have to check it in all the three inequalities. Okay, so I'm going to check this point first. It's a negative 6 and 4. Okay, so if you call it x and y, so this means your x is a negative 6 and your y is 4. So check these numbers into the 3 equation. If you check the first one, okay, that's it, negative 2x, that gives a negative 2 times a negative 6 plus 5y, it's a 5 times 4. You want it to be greater than or equal to 3. So that gives a negative 12. Okay, negative 12 plus 20 to be greater than or equal to the 3. So that gives you 8 greater than or equal to 3. The answer would be yes. So it satisfy the first one. Any question? Check the second one. In the second one, you have a y less than 4 and your y is, okay, 4. So that's it. Y equal to, is it less than, okay, that is going to be, yes, it's a less than 4. Okay, so this is it, your y is equal to 4. So in the second equation, it's not going to be satisfied. Let's get this one to be less than or equal to, okay, so it's less than or equal to 4. So it does satisfy the second one. Okay, so we go to the third one. We go to the third equation. In the third equation, and you check your x and the y, so it's going to be negative 4 times the negative 6 plus 2y, 2 times 4. You want it to be less than 7. So that gives a negative 24, okay, plus 8 less than 7. So that gives a negative 16 less than 7. So it does satisfy. Okay, so the conclusion is going to be yes. Yes, negative 6 comma 4 is the solution. Okay, the solution.
Wait, don't the -4 times -6 equal +24?
Oh, is it? Positive 24. Yes. So it's going to be the other way around. Okay, so it does not satisfy. Let me check to see what's that form. Okay, that's just double check. That's a negative 4x plus 2y, and I have a negative. Yes, okay, you are right. You are right. So this is going to be what? A positive 32. Okay, so this means no, it is not. Okay, thank you. Is not going to be the solution of the equation. Okay, so this is the way we are going to check. I think the second one is also is not. You can check it for yourself. So we may have a system of three inequalities or more. So if a point satisfies all of them together, in that case, that would be the solution of a system. So let's try one of them to see what we are going to be interested in. So that was just to refresh your memory. The thing that we are going to be eventually interested in it, you graph these systems, and there's going to be some special points of these systems that we are going to be interested in. Okay, so let's try this system. Okay, so example, we wanted to graph this system or solve the system. Okay, solve the system or graph, the solution, we mean. The system. This is a system that we're going to use later on. Okay, the first equation is x plus y greater than or equal to 3. The second equation is 2x plus y greater than or equal to 4. The third equation is x less than greater than or equal to the 0. And the next one is y greater than or equal to the 0. Okay, so this is the system that we are interested in. Okay, to get these numbers. So take each one of them and graph them in one system of the equations. Okay, are you ready? Solution. We go with the first one, x plus y greater than or equal to 3. If you like, you can solve for y so that you can see that it's going to be above. It's easier for this one. You don't have to. Okay, so get a couple of points for this one. Y equal to the 3 minus x. Go with the intercepts, that's easier. X, y, put x equal to the 0. Y would be 3. Put y equal to the 0. X would be 3. Okay, graph this one. So what we have, 3, 3, 1, 2, 3. And this is going to be 1, 2, 3. Okay, identify this point, connect them together. You get the equality, so that must be a solid line. Okay, this is going to be a solid. And, identify that this is the line that you are interested in. Okay, it's going to be 3 minus x, so that we're going to lose it. Okay, so this is going to be the case. we can identify the region of the solution. This is y greater than equal to, so the region of the solution is going to be up here. Okay, this is going to be the first part. Okay, are you ready for the second part? Because that was y is directly given to me, I didn't check the origin because it's greater than, it's going to be above. Okay, check the second one. 2x plus y greater than or equal to 4. Again, I can solve, for y, so that give me exactly the region on the top. Okay, y greater than or equal to 4 minus 2x. So y equal to the 4 minus 2x. Just pick a point. It's going to be x, y. I pick x equal to the 0, so that gives y equal to 4, y equal to the 0, and that give you 2. You can pick some other point if you like, but these are going to be easier. Okay, so we have a 0 and 4. So that was 3, this is 4. Okay, and we have 2 and 0. So this is going to be 2. So connected together, we get the equality, so there's going to be a solid line. Okay, so I'm going to connect these together. Okay, and this is going to be the result. Okay. So in this case, again, it's going to be greater than. So the greater than is going to be again above. These are going to be the cases that we're going to have. Okay. So far we get those intersections. So this is these are the point of the intersection that we have. Now the other one is x greater than or equal to the 0. You see x greater than or equal to the 0, we're just using the positive x's. Okay, we already got it here. Okay, x greater than or equal to the 0, and the y greater than or equal to the 0. So these are means, x greater than or equal to 0, y greater than or equal to 0 means you are going to be interested into the first quadrant only. The first, okay, the first region, if you like, to get these numbers. Okay, this is it, x, y. Now you can pick their intersection to see what's going to be the intersection that we're going to have with the x positive, y positive, and those two graphs. As you can see, this is going to be the x positive. You see x positive, and this is, I'm going to identify for you. So this is going to be the x positive. Then we get to this line. Okay, we get to this line. We get here. Okay, we get here. And this is going to be just going up here. Okay, going up here. And then the top here. Okay, so the region of the solution are going to be, okay, when we want to graph it, we don't graph the other parts. We just get this region so that we are not going to miss it. Okay, so the x positive, xy positive, it must be in the first quadrant. Okay, it's going to be the first quadrant. It's going to be above these two lines. Okay, the region that's going to be they share together. So what I did, I came here. Okay, so this is the green one. We cover the red one. So I get over here. Okay, then I get to the y-axis and just keep going up. Okay, going up. So these are going to be the region of the question for us. So For the, we just want to use the application of these type of ideas. What we are going to be very much interested in, these are going to be the points that is going to be the, you see, these are the boundary lines, we call them. You see, these are going to be boundary lines that we're going to check. Okay, so the points of the intersection and these boundary lines are going to be very much important for us. We call them the, okay, points of intersection, and we call them corner points, if you like, or vertices. So the vertices of these regions are going to be this one. Okay, remember that was for the, okay, so that was the point 3 and 0. You see, you get the 3 and 0. This is going to be one point of the intersection. Then that will take us to this point here. Okay, and take us to these points here, and the coordinate of this point is going to be 1 and 2. Okay, we can intersect it together. You see this point? This point is going to be intersection between these two lines. So that gives us 1 and 2. Okay, 1 and 2, and you have one vertices over here, and that vertices is going to be 0 and 4. Okay, so this is going to be the region of the solution, and the point that's going to be the intersection of the boundary lines, and they are going to be in the region, are the points that we're going to be interested in. Eventually, we are going to have something we call linear programming. It's quite interesting one. You get it for free here. But if you go on today, it's, you have a software and you write it down, the program to get it. But we can use this very easy idea over here. So I give you a remark for those points that we are going to collect. This section, they just graph it for you, but we want to get the idea. So the idea is going to be the points, okay? So those points, okay, those points belonging, okay, to the graph, that are also, okay, also points of intersection. Okay, points of intersection. Points of intersection of so-called boundary lines. Okay, boundary lines. The boundary lines of the regions are called, okay, these points are going to be called vertices. Okay, vertices or corner points, or okay, corner points of the graph, of the system, Okay, those points of the intersection between those boundary lines. It must be in the region and intersection with the, okay, the boundary lines that you have. You see, you have the x-axis, the y-axis, and these lines. So as we move on, we are going to check these points. Okay, let's just check this one again. You see the boundary lines over here is just the x-axis. You get to the first line. So this is the intersection of this green one and the x-axis, so 1 point. As we move on, we go to this point over here. You see this point is the intersection with the green and this red one. So in fact, if you want to find it, you see this is this is a situation that we have over here. You see, if we intersect y equal to the 4 minus 2x, and with the y equal to the 3 minus x, okay, if you intersect these two lines, you are going to get that intersection that I put, okay, I put over here. So this is going to be 4 minus 2x equal to the 3 minus x, and that gives you negative x equal to the negative 1. So your x would be 1. X would be 1, you substitute, and your y would be 2. So this intersection point, you see, this is the intersection point that exactly you get over here. Okay, so one of them, that was easy. That was easy because that was x intercept that we already talked about it. Okay, that was a 3, we can see it. Over here, I just guess, but it's consistent, the intersection of the, okay, of the green line and the red one. And when we go over here, this is another boundary point, which is with the y-axis. So that's going to be just y-intercepts of the red one, okay, which is going to be 0 and 4, and that takes you up there. For this type of function, there is going to be, okay, there is going to be a linear combination of the x and the y that we call it, okay, they give you a function, if you like, z equal to 3x plus 5y. Then they want to find the maximum or the minimum of these expressions. If you want to find the maximum and the minimum in this region, you just got to check these points only. So that's why we are going to be very much interested in. But we talk about it. Okay, it's going to be on Monday. Okay, when you're coming back. So just get to know them. If you haven't seen it before, just check a couple of problems in this section, and then we do it when you come back. We give you something. This next section, they call it linear programming. Linear programming is a kind of programming that they use for relocation of the resources to the different places. And for the first time, it was used by the United States Army during the World War II, when they want to, relocate the resources, okay, from America to Europe. And they have a number of the planes, and you have a number of the resources, and you want to make sure that you get, you get the best result, or the maximum that you can get. So they use this type of ideas, okay, to get it. But today, there is a software, you can write it down and get those numbers. So it's quite interesting application. You like it, you get it free or for nothing. Okay, so we talk about it on Monday, and we give an application, 2 problems from this one for your next test. Okay, so I check, and I probably post your practice test number 3, so that I think when you come back, you quickly, I should check the date that you are going to have your test number 3. So I grade the quiz number, okay, quiz number 3, I haven't done it yet. I posted for you, but I post practice test number 3, and then we are going to be, there is no class on Wednesday, no class on Wednesday. That's why I just try to give a little bit more to get it, no class on Wednesday, but I check the date for the next test. So I give you the practice one. Probably we cover this one. This is section 6.5 is just talking, just graphing, but we need it for the 6.6, which is the application, relocation of resources. We call it linear programming. I think that's it. Any question? So have a good night, take care, and see you again on Monday. Bye-bye, have a good night.